My sort of background is, as I was telling the people who were here a little bit earlier, I started with the Spring team in early 2006, and I came up through, sort of various different organizations within sort of the Spring team, working on various open source and commercial products, and eventually decided that I would move over on the Cloud Foundry side of the world, and I would help run what the Java experience was on Cloud Foundry, sort of made it this really, really great experience. If you're a Java developer, you're a Spring developer on Foundry, CF Push just does things for you. I then sort of transferred over to a new product inside of VMware called Tanzu. Tanzu is basically our attempt to say that great developer experience that CF had, what exactly does that look like on top of a Kubernetes substrate, which we saw a bunch of our customers asking for. Mark here?
Sure. So it's easy for me. Much of my background actually matches his, so I can just fill in the parts that are different. We both started around 2006, beginning of 2006 with SpringSource, and then we're both part of the acquisition into VMware in 2009, and then both part of the Pivotal spin-off, and now back at VMware. So the difference is, while Ben was working on Cloud Foundry, when I was at Pivotal, I was mostly working on something called Pivotal Function Service, which is where I started getting the experience with Kubernetes and the platform, and really trying to bring a lot of the ideas of Spring into the platform. When I was on the Spring team before all of that, I was mostly focused on messaging and integration, the Spring integration project in particular, and was also a contributor on the core Spring framework. With the annotation support when that first arrived, to be able to do things like auto wiring. So that's a fun bit of trivia. Yep, let's get started.
So the talk here today, like as Mark says, we both work on the project. This is a commercial thing that VMware sell you, but we both come from a long line of Spring development, which means we're not actually here to sell you on Tanzu. This is more a talk for you application developers about our observations, right? Like our primary purchasing customer is a platform engineer. But you're not platform engineers, you're app devs, right?
So did you poll the audience?
Oh, yeah.
Maybe it's a good place to start.
We were going to try and know, wow, how many of you are platform engineers?
All right, no, that's good, that's good.
Okay, so for both audiences, this is sort of designed to say, hey, like we have done a lot of talking to customers, we have a lot of background on application development teams, and we sort of have an idea of what platforms should look like. We're going to talk through that. One of the key things I want us to do, though, is remember that like this is a discussion, right? I'm not talking about any specific technology, any specific product, which means that we're going to leave a lot of time at the end so that we can have sort of a more open discussion. We're going to talk at high levels. If you want to go into detail, if you have some ideas that we didn't cover, let's talk about all those things. So here's what we're seeing. The old days, operations teams, right? Your IT operations team was this sort of central hub where they were responsible for all of sort of the bare metal servers, maybe virtual machines if you're VMware customers in your ear. And if you were any of these other personas, an application developer, an application operator, net security operator, something like that, a lot of your work was talking to that one central IT operations team or person, and then maybe they enable something for you, maybe they do something for you, but in a lot of cases they then sort of like send you off and say, hey, now you've got permissions to go to this particular server and do some sort of work there. And it required you to be this huge expert in Unix, for example, like all of these different things that maybe wasn't your core expertise. But what we've seen, this major shift in the industry over the last couple of years, is it's not enough to just sort of like one-off these things, right? I have a server, it runs an application, and I need to do this one thing to it. Instead, what we're starting to see is this move towards platform engineering, that teams, internal teams inside of these organizations are creating platforms. And those platforms end up being used by all of these different personas, right? The same sort of work needs to be done, but it gives us an opportunity to say, hey, there is a platform here, and a platform engineer is responsible for keeping that alive and actually, sort of delegating out to all of the physical hardware, the virtual hardware, the cloud hardware that they had access to. But all of those other personas come to that same point without needing to talk to the platform engineer.
Yeah, so I think one thing before we get into the next topic is just to kind of put this into the perspective of the DevOps movement, right? There's a lot of hype right now around platform engineering, and there's some discussion around DevOps is dead, platform engineering is the future. DevOps as a movement started to solve specific problems like not having to throw your code over the wall to a separate team that would then take it from there, but to create a self-service experience. And likewise, it's not a coincidence that the DevOps movement also kind of coincided with the cloud, and the cloud started as self-service APIs for infrastructure and has continued to evolve to be self-service APIs for data services, self-service APIs for continuous integration, all of the things that start to become more and more relevant to developers. And so in some sense, the DevOps movement is turning into platform engineering, which is just a matter of bringing more structure to that because it's a wider range of problems that are being solved by a wider range of different roles that come together there.
Right. So this is an opportunity. I say this for application developers, which is what we thought we were going to be talking to. I'll say this for platform engineers as well. Like, this is a moment, right? The introduction of this new way of thinking about this problem, this introduction of the idea of a platform, to ask, what should your platform do? As an application developer, what should you be asking your platform engineering team to provide for you? As a platform engineer, what should you be providing for your application team so that they can be productive? And so we've got 5 things that we're going to go through. First one is this platform needs to be treated like a product, right? We start back here. There was a lot of one-offing, right? Like, you all needed to talk to an IT operations team so that they would go through and grant you permissions or would do some sort of work for you on a very one-by-one basis. But even in this case, right, where we're going to this idea of a platform, we end up with a problem, right? If all you're doing is all of these different personas are still routing to a platform engineer, that platform engineer, in addition to making sure that this thing is always alive, always highly available, all of the hardware underneath it is scaled to the things that they want to do, are also now having to sort of handle a bunch of incoming requests and understand the priority to the business. And like, I don't know, most of the platform engineers I've talked to would love to just continue hacking on their hardware, hacking on their platform, not actually have to handle any of the product stuff. So the very first thing that we recommend for all of our customers, and we see all of our really successful customers doing, is literally introducing a product manager, which is generally not something that you'd expect to see coming out of an operations team. That there is some sort of person who listens to all of these requests, many, many requests from all of these different teams, and really prioritizes for the platform engineering team what's important, what should we actually build.
So again, going back to the whole idea of DevOps, I think that DevOps has been interpreted in different ways. Sometimes it means developers do all of the ops because now they're APIs and developers can work with those. But in reality, it's, I think, more successful when it's viewed as developer concepts are actually applied to the operations side of the house. And one of the things about having this as a product is that you're recognizing that you need a team that's going to not just build it once and then be done and hand it to the developers, but like continue to maintain that, which is why the role of the product manager is important. And depending on your culture, you might have developers who want to enhance the platform in a certain way. So if your culture is open to it, the idea of something like an inner source model allows the developers to contribute, right, to the parts that actually will make their life easier, but not to have to completely own all of ops in the DevOps sense.
Yeah, this is really tied to this idea that there's a lot of stuff in sort of central IT that's moving from CapEx to OpEx. That like this is no longer a capital expenditure where you pay once and then you're done and you just run it for some period of time. All of these projects, whether it's something like introducing a platform or whether it's just getting your email service, is now considered an ongoing cost and ongoing effort that will happen basically indefinitely. So number 2. Big thing you want your platform to do for you as an application developer, or to do for your application developers if you're a platform engineer, is to shift your outcomes left without shifting the burden of those outcomes left. And so if we take a look at like sort of the experience today, an application developer has some sort of build pipeline. At the end of that build pipeline, it deploys out to the platform. right? Now all of a sudden, our NetSec operator comes in and she says, hey, there's this new requirement. Absolutely everything needs to be MTLS. And you're like, okay, well, we can probably just put that inside of the platform. Then it comes along who did I say this was gonna be? Our compliance operator. Compliance operator says, hey, we need to do something, something, something so that we're SOX 2 compliant. And that goes into the platform. And all of this is going great. But then what we see is all of a sudden your application developer's velocity drops. And it drops because they're still using their build pipeline, but when things get to production, it turns out they weren't conformant, right? They aren't going to work in the current network situation. They aren't going to be compliant with SOX 2 or something like that. And so we always talk about this idea of shift left, right? Let's find that earlier in the process. And almost invariably, that becomes shift a burden onto the application developer. Application developer needs to know about all of these requirements, needs to understand how they're implemented, needs to make it part of their developer workflow to understand and implement all of this stuff. And maybe that's good if there's only two. But what happens when, as Mark likes to call this slide, we have a couple versions of it, the village people show up, right? All of these requirements get dropped onto our application developers. And this is really problematic because what you end up with is a development team that has to be a master of everything, they aren't, and needs to do all of this in addition to actually developing valuable products. And so this just doesn't work. So the goal here is instead to have all of that same group of people all contributing to a central place, right, to the platform itself. And make sure that the platform isn't just a runtime, right? It should also encapsulate your build process. So what we want to do is when that developer commits code, there is something that happens both build time very, very early on where they can detect whether or not all of their stuff is going to work, and then also at production time guaranteeing that all of those same things exist there.
Yeah, so I think this idea of shifting left is about recognizing things early, but not necessarily making it a blocking distraction, right? Thinking about recently my windshield wiper fluid light came on in my car, right? I don't stop right then and grab the wiper fluid because it was a sunny day, but I knew that I needed to deal with that before the next time I was going to be using the windshield wipers. But in maybe a more real-world example that applies to a platform is the everyone's favorite topic, managing CVEs, right? It's something that has to be done. In a pre-shift left mindset, you could say that, or like an incorrect shift left mindset, I should say, you might have a blocker, like a gate into your, like an admission controller into your Kubernetes cluster that says you can't have any high vulnerabilities for any of the deployed applications. And then you put the burden on the team to make sure that they're scanning and generating their SBOMs so that you have something to look at to make that determination. But the problem is, in the real world, CVE management is never just this black and white, I have a vulnerability or not. You have to do triage, right? So when we think about the platform as shifting things left, it's always important to figure out where you're going to draw the line. Who has the context to solve this part of the problem, and who has the context to solve the other part of the problem, and how do we create a self-service automated API that sits right between them, right? So developers have to do the triage. They know whether or not this particular vulnerability is exploitable, and most CVEs end up being false positives, right? They can actually create the VEX document that determines that, and that can be used by the system, right? So that's an example where you're shifting left. The developer does have to do something, but if they have a platform that gives them the tools, that allows them to use a build that generates an SBOM, it allows them to do triage through a tool that maybe also shares all of the triage information from everyone else using that platform, so you can see common things like we have a vulnerability here. This other team had the same vulnerability. They determined it wasn't exploitable for the same reasons that I can. We can share that information, create this document, and now it will go through that pipeline. But again, it doesn't mean that just because that vulnerability shows up, you have to stop what you're doing, stop developing your application and go solve that problem. You could do it, any time between now and when you're going to be going into the production environment, because you have this red light in front of you that's telling you that this is not going to make it into production.
I think one of the other big points here is the story of collaboration in this case. Like, I think what we're starting to see more and more, especially the larger you go in organizations, is that some of these requirements end up being really, really specialized, and you're not going to end up with one single person or one single team that has the context to do some of this stuff. Like, I don't expect an application architect that knows that they want to use Spring Cloud Gateway as the gateway for every single one of their applications so that they get off to be the same person that's the NetSec operator and knows that all sort of east-west communication needs to be MTLS encrypted. And you want a platform to really optimize for that collaboration between all of these different people who have a huge amount of expertise in the work that they do and almost no expertise in the thing that their peers do. So number 3, paved paths, right? You're an application developer. You're a platform engineering team with application developers, and you know each one of these teams knows that they need to get to their staging environment. And what exactly do they need to do that? Do they need to have some sort of initial CVE scan? Do they need to generate an SBON? Is there some sort of standard way that they need to generate the Kubernetes YAML? We're Kubernetes people these days, but sub in whatever your favorite platform is right there, right? And that team spends however many hours it takes to actually figure out what that is. But then another team comes along and attempts to do the exact same thing. And if everything goes right, they do actually build the same thing. In reality, almost certainly there's some sort of divergence, some little niggles here and there that aren't there. But hey, that's another team, that's a second team. What happens when the third team comes, right? And they have to spend those same number of hours, right? You application developers end up spending the same number of hours trying to reinvent that wheel. At Pivotal, we used to have a 3 strikes and you're out rule. At this point, somebody goes off and adopts this and becomes a thing. But realistically, in all of these other organizations, everybody goes off and does this, right? And ignore for a moment the inconsistency and whether your enterprise is prepared to tolerate that kind of inconsistency. Once one of these teams sort of figures out the way to do this that's sort of acceptable to everybody, it is important to pave that path, right? To come back and say, actually, there's one way that we go to production, right? This is how we get to staging. And so this often looks like sort of a build pipeline traditionally. You're going to see people sort of standardizing this kind of thing, but it goes a little bit further than that, right? Like if there's anything that looks like you get to figure out how you get from staging to prod or from, you know, sort of your initial prod to a totally scaled out prod, everybody's going to try and do that differently as well. So you need to make sure that that ends up being sort of the same at the same time. One of the things I do want to caveat, though, is we see customers try and do this. There is one golden pipeline. There is one golden paved path that everybody will use. But we also recognize that that's not true, and it's becoming less true by the day, right? Like maybe you're a green team, maybe you're a spring team, but what happens to the team next to you that's working in Python or is working in Go? Like this can't work. And so there is a balance between you are going to all use one pipeline, or you all get to use your own pipeline. And instead, what you're really looking forward to, or you're looking to do, is to actually identify classes of applications, is the framing that we use. Inside of your organization, you've got 1,000 different applications, but really, you've only got 5 different kinds of applications. And if you can convince application development teams, if you can be convinced to go into smaller and smaller, or a smaller box than basically you can do anything, it gives you an opportunity to say, I don't have to spend a huge amount of time here.
Yeah, so we like to talk about this as micro platforms, right? You can have a single platform, but it actually supports different types of experience. And part of that, in these paved paths, you can also bring the common services that are needed for that particular type of application. So if it's a Spring Web application, the paved path might include the configuration of a Spring Cloud Gateway, so that when the team pushes their app, they don't also have to deal with that. They just deal with the app's binding to that gateway, right? Because there's the gateway itself, and then there's the application saying, I need to have a route on that gateway. Likewise, you might have machine learning apps, and they need to integrate with libraries and services that are available to those for, you know, serving a language model or something like that. That could be part of the access to that service, could be part of this paved path, so that there's even less for the developer to have to do. So we kind of call that this idea of micro platform. But also, when you're doing microservice development, it's really helpful to have a paved path that allows you to have the independence of, you know, the team building microservice A and the team building microservice B can deploy independently. And they can each use the same paved path, but land in an environment where you have the shared services between those so that you don't have to create what often gets referred to as a distributed monolith, right? So all your microservices live together, they all get deployed together. And that's something else that you can handle with these paved paths if you get that level of granularity right and they have the shared services. The last thing I'll mention here is that there is some leeway. We know that you're going to probably have building container images, scanning container images to generate those SBOMs as part of these paths. But a lot of the path is going to be templating out the configuration, right? There's a bunch of YAML at the end of the day that gets deployed onto the platform, right? And you don't want developers to have to write those thousands of lines of YAML, so a big part of this will be templates with just enough to fill in what the developers need to bring with their context. And there's leeway there, depending on how much you want to have constrained environments for your teams or how much flexibility you want to give them in terms of how much of the template they can fill in, basically.
Number 4, you want your platform to encode runtime services in opinions. So many of you are really good application developers, you've written a really good app, you know exactly how to get that to deploy locally on your laptop. But you're also realistic, right? Laptop is not where this is going to run. And so you're asked, hey, can you figure out how to get this to run in our data center? What do you need to learn, right? You need to learn that there needs to be an API gateway. You need to learn how to provision or connect to a database. You need to understand how your pipeline is going to integrate with this particular data center that you've got. But then the next requirement comes down, right? Next requirement is, okay, so I'm an application developer, we're headed to the cloud, right? This is the big thing from your CIO. We want to save some money that way, even though you're not going to save any money that way. Now all of a sudden, in addition to all those things you knew before, now all of a sudden you've got to learn Kubernetes, right? The blue box. And you've got to learn how to use RDS instead of the database that you had on bare metal. And you've got to learn about what the hell this thing called a GSLB is. And you're like, okay, so I'm spending a lot more time than I thought actually learning about all of these sort of deployment topologies and things like that. Somebody comes out and says, now we need this thing to be high availability. Now all of a sudden, in addition to everything else you've learned, you start realizing, oh crap, I've got to know about regions and what east-west across regions looks like, what the implications around shared data is, and what it means for us to have good latency depending on where the customer is. And all of a sudden, you're really starting to realize that actually, I'm doing a lot more of this infrastructure work, right? Rather than actually doing application development, really focusing on the things that generate business value. And then somebody comes to you and says, sovereign cloud, and you immediately start Googling to find out what the hell a sovereign cloud is and why you need to be there. But then it's requirement after requirement. You need observability, you need cost optimization, you need A/B testing. And there's only really one outcome for an application developer at this point, right? It's all over, right? There's no way. They've stopped doing actual application development. And so one of the key things here is if you as an organization have opinions about these things, that should be baked into the platform, right? Application developers focus on applications. All those other personas deliver a platform that encodes all of this. An application developer may know this needs to be highly available, but they don't need to know how high availability happens. They just need to be able to market, hey, this app needs to be highly available. It needs to be in, sort of an EU sovereign cloud and be done with it.
Yeah, so I think this ties back to that theme of DevOps and like the fact that in a lot of cases it means too much ops gets handed to the devs. No one can truly be an expert in all of this stuff, right? Like even when we talk about full stack engineer used to mean you could do front end work and back end work, and that's pretty rare even for that level. But also being able to do network administration and also be able to manage everything that's involved in compliance on different clouds is probably not something that a typical developer can do. So not only you're increasing the cognitive load on the developer, but they're likely to cut corners because they just want to get back to building their application. And this is the fundamental tension, right, between the platform engineer, the network operator who do have that domain expertise and who are probably the ones on the line if something actually does go wrong. They don't want to just hand it over to the developers. So being able to bring that into the platform, then application developers view this as undifferentiated value, right? They want to focus on the part that's portable. I've got this application, it runs on my laptop, it runs on Kubernetes across 3 regions, right? But what the part that they really care about is the REST endpoints do their job, the data is stored in the database, like that's where they want the end of the scope to exist for them, from their perspective. So like the platform can give them that portability of their experience and handle all of the different variation and let the true experts handle the networking and all of those concerns.
Yeah, these dev teams all chose Spring Boot so that they could run the same thing locally and in production. Like, let's help them do that without putting on all this extra burden. And the final thing that we think your developer platform should be providing for you is a developer portal. Like, we as developers, like Mark and I, just the same as everybody else, we have to talk to source. We have to go look at observability. We have to check whether our CI/CD is healthy. One of the big ones is, like, suppose I need to go talk to some other team about exactly, what's gone wrong, right? Or how they're expecting us to use the API. Or even sometimes, sort of at the level that we are you all on schedule for delivering this feature that we know another team actually needs? And what we end up with is application developers with a stack of bookmarks that they need to go to all of these different places every single day. And really what you want is a single developer platform, right? This isn't true for platform engineers or for any of the other personas, but application developers, again, with this idea that you want to be spending most of your time working on code, doing business value, like creating business value. What you really want is one place that you go to, right? A developer platform or a developer portal that starts, and it brings in all of the things that you might actually want to look at on a given day, all into one specific view. I think one of the things many people, especially if you're DIYing a developer platform today, is they think that this also needs to be the be-all and end-all, right? The developer platform is the only place anybody goes and pulls their observability, the only place anybody goes to look at their CI/CD status. And I want to encourage all of you to realize that this does not have to be true and almost certainly isn't true. Most of the time, we see developer portals used successfully as sort of there's no good term of art for it, but I would refer to it as triage, right? Tell me if there are any new issues, any new MRs. Tell me if I've got some sort of alerts or something like that, and then link me out, sort of deep link me out to something that has a lot more detail, focused very, very heavily on this particular focus, right? I would never try and embed all of Datadog inside of my developer platform, but I would do a dashboard for it and then kick you out to Datadog to do the really sophisticated stuff. And what I believe is the only example in here, one brand name, Backstage. If you all haven't started looking at Backstage, I love it to death. We built a product on it, but I loved it even before we started building a product on it. This is very much today the place where developer portal sort of innovation is going on right now, and I highly recommend it.
Yeah, and there's a social aspect to this as well. In fact, if you look at the blog on Spotify, they're the ones who originally created Backstage. They talk about that being the reason that they created an internal tool that they eventually decided to go with Backstage as a community project. So the idea is you're constantly trying to find out information about this other team, or even even discovering the fact that these other teams exist, or that someone's already created the user account service, so maybe I don't need to create a new one. Solving that problem and avoiding the situation where you go onto Slack and you ask someone that that works in that part of the org if they know who the tech lead is of this project because you have a question about the API, right? If you have a developer portal, then you can find that project, you can find the API documentation for that project, and hopefully that's all you need to know. If you do need more detail, then on the same developer portal, you have links to the actual team members and who is the current tech lead, right? And all of this should be kept up to date because it's backed by a software catalog that you can feed from the information sources within your org. So it's pretty powerful when you really embrace it and use the discipline to keep it up to date.
Okay, and that's it. So if you're getting a platform, what should it be doing for you? Make sure the platform team treats it like a product. Make sure that they're shifting outcomes left without shifting the burden left, making sure they're providing paid paths and coding runtime, services and opinions, and providing a developer portal for you. And with that, from Mark, me, and the whole team, thank you, and we're happy to take questions.